Welcome to another live CSEC class, and we're looking at algebra today, how to subtract algebraic fractions. Now, the procedure for subtracting algebraic fractions is the same as for subtracting regular fractions. We find the LCM and we divide the denominators into the LCM, multiply the answer by the numerator, and then we simplify the numerator and put it back over the denominator, right? So it's the same principles. So we're gonna do some examples of subtracting algebraic fractions. So let's go. Vamos. All right, so let's say we have, let me choose. So let's say we have x over 5 minus 2x over 8. All right, so we're simplifying. So the LCM of 5 and 8 would be 40. And 5 goes into 48 times. 8 times x is 8x. And 8 goes into 45 times. 2 5s, 10x. So we'd end up with a negative 2x over 40, which we can simplify. And that's a negative x over 20. So we find the LCM, which is 40. 5 into 40 goes 8 times. 8 times x is 8x. 8 into 40 goes 5 times. 2x times 5 is 10x. 8x minus 10x is negative 2x. Put it back over the 40 and we can cancel. 2 into 2, 1, and 2 into 40 goes 20 times. Let's try another. So x over 7 minus x over 9. And the LCM is 63. 7 into 63 goes 9 times. So 9 times x is 9x. And 9 into 63 goes 7 times. X times 7 is 7x. And this is as simple as it can go. We can't, well, no, it's not. We can subtract. So 9x minus 7x is 2x over 63. All right, and 2 can't go into 63 without a remainder. So this is the answer, 2x over 63. All right, how about 5x over 4 minus x over 7? So the LCM of 4 and 7 is 28. 4 goes into 28 7 times. 5x times 7 is 35x. 7 into 28 goes 4 times. X times 4 is 4x. 35x minus 4x, that's 31x over 28. Okay, so how about 2 over 3xy minus 1 over 2x. All right, so in the denominators, we have variables. We have xy, we have x, and we have to represent each variable in the LCM. And the LCM of 3 and 2 is 6. So 3xy into 6xy goes exactly 2 times. Xy cancel each other. And 2 times 2 gives 4. 2xy into 2x into 6xy goes 3y, because the x cancels, this x cancels that one. We're left with y, and 2 into 6 goes 3. And 1 times 3y is 3y. And this now is our final answer. It cannot be simplified. There is nothing that we can use to cancel the 3 and the 6 and the 4. And it would have to cancel all 3 terms, which only one can divide into 3, 4, and 6. Okay, so give me some feedback so far on the subtraction of algebraic fractions. So remember, we find, John is saying it's easy. Okay, I agree, John. We find the LCM just like with regular fractions. We find the LCM and we divide each denominator into the LCM, and the answer that we get, we multiply it by the numerator for each one. After we do that, we simplify the numerators. So we combine the like terms in the numerator, put it back over the denominator or the LCM. And Ngozi says she's getting it. This is great. So when we get our answer now, we see if it can be reduced. But remember, if you have 2 terms in the numerator and 1 term in the denominator, you can't cancel them. If you can find a number that can go in one of the terms in the numerator, but not the other, you can't use that number. So with this one that we're looking at here, 3 can go into 6, but we can't cancel the 3 and the 6 and leave the 4. 4 can go into 2 can go into 4 and 2 can go into 6, but we can't cancel these 2 and leave the 3. So when it is set up like this, we have to find a number that can cancel all 3 terms, or we cannot cancel any of the terms. We can cancel 2 and leave the other one, or cancel these 2 and leave the other one. So let's do some more. 10 over 3xy minus 2 over 6y. All right, so the LCM would be 6xy. 3xy into 6xy. The xy's cancel, and 3 into 6 goes 2. So that's just 2. And 10 times 2 is 20. 6y into 6xy. The 6 is cancelled, the y is cancelled, so we're just left with x. And 2 times x is 2x. So that would have been our final answer, but we can use 2 to cancel the 2, the 6, and the 20. Can't use x because, we can't use x because this doesn't have an x. So 2 into 20, that goes 10. 2 into itself goes 1. And 2 into 6xy goes 3xy. All right, so 2x minus 3y over 5w. So let's put this over 1. And the LCM here then would be 5w. So 1 into 5w goes 5w. And 2x times 5w is 10xw or wx. And 5w into itself goes 1 time. And 3y times 1 is 3y. And that's our answer because we can't simplify this any further. This is as simple as it gets. So let's say we have 7 minus 2x over 3p. And we know that's 7 over 1. The LCM of 1 and 3p is 3p. 1 goes into 3p, 3p times. And 7 times 3p is 21p. 3p into itself goes once, and 2x times 1 is 2x. All right, so let's see. The LCM would be 15bx. And 5b into 15bx, that goes 3x. 5 into 15, 3, and the b cancel b. So 2x times 3x, that would be 6x squared. 3x into 15bx, that goes 5b. And 6 times 5b would be 30b. All right, so this can be simplified. We can divide each term by 3. So we'll be left with 2x squared minus 10b over 5bx. So in this case, we can use 3 to cancel because 3 can go into the negative 30, it can go into the 15, it can go into 6. All 3 of the terms, 3 can go into, so we can use 3 to simplify. All right, so feedback. Let me hear how it's going. Easy peasy or hardy party? So John says it's easy, and Gozi says it's getting easy, getting easier. Najara says he agrees. So let's work about 4 more then, just for good measure. Let's do 4 more and then we wrap this up, and then you can do some on your own. All right, so 2 over 4x minus 3 over 9 . All right, so let's mix up some addition and subtraction. So the LCM here would be 36x. And 4x into 36x goes 9. 2 times 9, 18. 9x into 36x goes 4. And 3 4s 12. Plus x into 36x goes 36. And 6 times 36. 6 6s 36. 6 3 is 18 and 3 21. So 18 minus 12, which is 6, plus 216, that's 222 if I'm not mistaken, over 36x, and reducing that by 2, so that's 111 over 18x. All right, so look at that and tell me if I did everything right. 1 over x minus 6 over x plus 12 over x. Let's put some numbers. Let's put 4, let's put 5, and let's put 10. So I'm just grabbing these numbers out of thin air. I don't even know if they're going to work out. All right, so the LCM of 5x, 10x, and 4x, so that will be 20x. 5x into 20x goes 4 times. 1 times 4 is 4. 10x into 20x goes 2 times. And 6 2's 12. 4x into 20x goes 5 times. 12 5 60. 4 minus 12, that's negative 8. Plus 60, that will be 52 over 20x. And reducing that by 4, so that will be 13 over 5x. All right. So 2 more. All right, so we're doing 2 more. 10 minus 3x over 5 plus 7x over 3. So we know we need to put this 10 over 1. Always do that. The LCM of 1, 5, and 3 is 15. 1 into 15 goes 15 times. And 10 times 15 is 150. 5 into 15 goes 3 times. 3x times 3 is 9x. And 3 into 15 goes 5 times. 7x times 5 is 35x. So we have 150, negative 9, plus 35. I believe that would be 26x. All over 15. And since there is nothing that can cancel 150, 26, and 15, so this is how we leave it. And the last one for the road, 8x minus 15x over 4 plus 9 over x. And we're going to put that over 1. And the LCM of 4 and x is 4x. 1 into 4x goes 4x. 8x times 4x would be 32x squared. 4 into 4x goes x. 15x times x, that's 15x squared. X into 4x goes 4. So 9 times 4, that's 36. And we would have grouping the like terms, so 32x squared minus 15x squared. So that gives 17x squared. We have a 36, which is by itself. There's no other whole number. And in the denominator, we have 4x. Excuse me. So that's the blessing on this lesson. So look at what we've done. Let me know if you have any questions. Look at what we've done. So we find the LCM, use the denominators, find LCM, divide each denominator into the LCM, and when you get the answer, multiply that answer by the numerator, the corresponding numerator. So whichever denominator you use to divide into the LCM, multiply the answer by that numerator above it. And then you combine the numerators if you can, group the like terms. If you can't, just write it back as is. And when you get your final answer, see if you can simplify it by canceling. But remember, if you have 2 terms at the top and 1 at the bottom, you can only cancel it if you find a number that can go into all 3 terms. Or if you have 2 terms at the bottom and 1 at the top, same thing. You can only reduce it if you can find a common factor for all 3 terms. Okay, so no questions. I don't see any questions. So we're going to wrap this up for subtraction of algebraic fractions. And now I'm going to give you some to try on your own.